Alright guys, here's our review for the exponential and logarithmic units. Okay, when we are talking about exponential equations, there are two types that we have. Ones where you can get a common base. I want you guys to notice this. Common base ones, like 7, 7, 27, 243, right? These are all things that I can put a common base on. And then we have ones where we cannot get a common base and we have to use logs to solve it. Those are the two types, okay? Alright, so let's check this out. When you guys see that it already has its common base, right? Remember we said we could just set the exponents equal to each other. Okay, so I'm going to get x squared minus 6 equals 3x plus x squared, and then we solve it. This is starting off looking like a quadratic, but it is actually not, because when I get the x squareds on the same side, those cancel out. So now I can just solve this like normal, and I get x equals -2. Okay? Alright, we're going to have to do a little bit more work on this because, you know, we know that 27 is 3 to the third, and 243, pretty sure it's 3 to the fourth. Okay, if you're not positive, you are allowed to use calculators. So just come over here and see if you're right. So I was thinking 3 to the fourth was 243. Oh, I'm so wrong. 3 to the fifth. Good thing I checked, everybody. Okay. So, we've got calculators. You got decimals. You guys will be able to check. 3 to the fifth. Okay. So now, the way I'm going to rewrite this is 3 to the third, but also because we have to bring it up, it's 3 to the -3. Okay. 2x plus 18. And then this one is 3 to the 5, x minus 2. Once you guys see that we have the same base, we're setting the exponents equal to each other, and we just go ahead and distribute here. Okay, so that gives me -6x minus, what's 3 times 18? 30, 46, I think, but let me confirm that. 3 times 18. Okay. Oh, 54. What on earth, you guys? Whew, good thing I'm not guessing the numbers correctly. All right. Anyways, and then 5x minus 10. Okay? Perfect. So when we solve this, I'm going to add 6 to the other side. Okay, and that gives me 11x. And then I'm going to add 10 to the other side. And that gives me -44. And so when I divide by 11 on both sides, x is -4. Okay? Alright, let's get our same base over here. 25 is, I'm not going to screw this one up, 5 squared. 625 is 5 to the fourth. And then that's 5 to the first. But these two I'm going to have to bring up. Okay, so I rewrite my equation like this. 5 squared to the x squared minus 8x. 5 to the -4. 11 minus x. And then 5 to the -1 to the fourth power. Okay? Again, we're going to say that equals that and that. Now, because of the times right here, we know that that means that we add the exponents on that side. So you guys, here's what this is going to come out to look like, okay? Distribute that. So 2x squared minus 16x. Distribute that. -44 plus 4x. And then, multiply those. And then just put -4. Okay? Alright, great. Let's see here. Let's get everything on the same side. I am going to subtract the 4x over to the 16. Okay, so this gives me 2x squared minus 20x. And then if you put 44 and 4 together. If I add those together, that's negative 48. So when I add it over to the other side, I'm going to add 48. Okay? All right, we're going to factor that. Now, this has a 2 in front, but that's all right. We want to do is we're going to just take the 2 out. So it says x squared minus 10x plus 24. And then we can get 2 answers, okay? Because that's x minus 6, x minus 4. So my solutions are x equals 6, x equals 4. Okay, remember, there really is no such thing as extraneous solutions when we're talking about exponential equations. All right, all solutions are good solutions. Okay, we just kind of divide this up here so it looks nicer. That looks weird. All right, anyways, you guys, this one we're going to use 2 as my base. That's 2 to the 5th. That's 2 to the 2nd. That's 2 to the 1, which I will bring up to be negative 1. So it rewrites like this. 2 to the 5th, x minus 4, equals 2 to the 2nd, 3x minus 5, times 2 to the negative 1, 2 minus x. Okay? We're going to distribute all of this. And remember that now that we have the same base, we're just going to let the exponents be equal. So I don't have to write the 2 anymore. So here's what I've got. I've got 5x minus 20 for that one. I've got 6x minus 10, and then negative 2 plus x. Okay? Now this one is linear. It's not quadratic. So we need to get everything on the same. The x is on the same side. Okay? So I'm going to subtract the 6x and the x. So I get negative 2x. And then I'm going to add the 20 over here. But then negative 10 and negative 2 is negative 12 plus 20 is 8. Okay, and then when I divide it over, x is negative 4. And that's my answer. All right, so that's how we do questions that have the same base, a common base. Okay, now we're going to look at some logarithmic equations. There are 2 types of logarithmic equations, okay? There is the type that has a log on both sides, right? And then there's the type that have a log on one side. Now, when they have a log on both sides, you know, it's pretty straightforward. We're just going to say that we can get rid of the log 4s and solve this equation. Okay? I want to get everything on the same side because this is a quadratic. I'm going to minus 8k and I'm going to minus the 5. So I end up getting k squared minus 8k plus 12 is 0. All right. Factor out. What multiplies to make 12 and adds to make 8 is negative 6 and negative 2. So my answers are k equals 6, k equals 2. Now, the one thing you have to be careful of with logarithms, you don't have to worry about this too much with exponentials, is that when you plug it in, it cannot give you a negative value there or there. But we're good because when I plug in 2 or 6 to either of those, they gave me positive values. So those are my answers, okay? No extraneous solutions on that one. All right, let's solve this one. Now, when there's a plus, you guys know that that means that we multiply on the inside. So 9x times x is 9x squared. And then we say, okay, there's an ln on both sides. When it's on both sides, you can just cancel it out. You can get rid of it. So I have 9x squared equals 25. You guys can decide if you want to do that by factoring or square rooting. In class, we've been pretty much doing square rooting. Okay, so x squared is 25 over 9. I'm going to leave it as a fraction because those are both perfect squares. Okay, so it's plus or minus 5 over 3. Now, when we check this one, when we go to put them in right here, or here, actually, the positive one works, but the negative one is an extraneous solution. So we don't want to pick the negative, and we're just going to pick 5/3. Okay. Now, when you have a log on one side, you guys, it's a different process. You have to go like this. Boom, boom. Okay. So we go 9 to the 1/2 equals what's on the inside. Now, 9 to the 1/2, remember 1/2 means square root. The square root of 9 is 3. And then I can add 18 to both sides. And then divide by 7 on both sides, so W is 3. And when I plug 3 in, it's a good answer. It's not extraneous or anything. Okay, we're just checking it into right here and making sure that it's a positive number. All right, last but not least, now let's get the log by itself before we start. So the easiest thing is going to be subtract 4. So it says -3 log 4 11c plus 9 equals -9. And then divide by -3. So it's log 4 of 11c plus 9 equals 3. Okay, now I do this thing. Boom, boom. So I get 4 to the 3rd is 11c plus 9. Okay, 4 to the 3rd is 64. If I subtract the 9 over 64 minus 9 is 55. And when I divide by 11, c is 5. Okay, and again, it's not making this a negative. That's what we check it into, so we are good. All right, perfect. Now, these are the ones that are a little more difficult. Expect these questions to be kind of a little bit harder, okay? So when we are solving exponential equations that do not have the same base, you guys, what we need to do is take either the log or the ln of both sides. I'll kind of switch it up. Some I'll put log, some I'll put ln. So here I bring the 4x down in front. So it says 4x ln 7 equals ln 172. Okay, I want to divide by ln 7. Okay, so I get 4x equals, and then you guys, that's a decimal, which I'll get in a minute, and then we just divide by 4. Put that whole thing over 4. Okay, now, I do want you guys to put these into decimal form, but we talked about how doing it in Desmos is like the easiest thing ever. So what we're going to do is go divide, divide. We're going to hit it twice, because there's like 2 divides here, and then you just use your keyboard and type in ln 172 over ln 7 over 4. And it gives me a decimal that I usually just go, we're going to go to 3 decimal places. And if you want to round, you can, or if you just want to cut it off, that you can. So it's 0.661. Okay? Let's look at the next one. Before I take the log of both sides, we can definitely just add this 7 over, make it a little bit easier. Okay, so it says 1/3 x minus 5 equals 11. ln both sides. Bring that down in front. So x minus 5 ln of 1/3 equals ln of 11. Now again, we're trying to solve for x. We're getting rid of stuff one at a time. First, I'm going to get rid of the ln of 1/3. Okay, that gets rid of that. So it says x minus 5 equals ln of 11 over ln of 1/3. And then I'm going to just add 5. Okay, and I'm going to go type that in. So now I'm going to type. And remember that you can use log or ln. In fact, I'll show you with this one. I'll do log. So let's say I used log instead. So I'm going to type in log 11 over log 1/3. 1/3. Oh gosh. I'm going to have to put it in parentheses. 1/3. Okay. That was a struggle. Plus 5. All right. There we go. Okay, so that's what I'm going to put. X equals 2.817. Okay, great. My next one, you can use ln or log. This one I'm definitely going to use ln though because it does have this e in there. But let me get the e by itself first. Subtract 8 from both sides. So I get 2e to the 4x minus 8 equals 15, I think. 15. When I divide both sides by 2, you can leave it as a fraction or you can write it as a decimal. 15 divided by 2 is 7.5. And then you could choose to log or ln both sides. Well, this one, I'm definitely going to choose ln because the 4x minus 8 comes down. And you guys, ln and e are inverses of each other. Okay? And when I bring it down in front and you have ln of e equals 1. Okay? And then I'm going to do two things. I'm going to add 8. Okay, so 4x equals ln of 7.5 plus 8 outside of the ln, and then I'm going to divide by 4. Okay? So we go like this. Sorry. All right. We're going to go ln 7.5 plus 8 over 4. Okay, and there's my answer. 2.503, or of course if you round to 2.504, that is fine also. Okay, so that's when you take the log or ln on both sides. All right, one more. Oops, I'll go ahead and use log on this one, I guess, because we haven't yet. All right, bring these down in front. You guys remember that this is kind of a long process, takes some work, but hopefully it's not too difficult. All right, first I'm going to take the log 5 and distribute it back. So it's x log 5 minus 3 log 5. Okay, and then I'm going to take the log 4 and distribute it back. So that's 2x log 4 plus 1 log 4. Now we want to get the x's on the same side. I'm going to go ahead and subtract this one over here to this one. So it's going to say x log 5, and when I bring that over, it'll be minus 2x log 4. And then I'm going to add this one to this side. So this side will say log 4 plus 3 log 5. All right. Then you factor out an x. So over on this side, I say, okay, there's an x there and an x there. When I factor it out, I have log 5 minus 2 log 4 equals log 4 plus 3 log 5. And then finally, at the end, I divide this whole thing over so I can get x by itself. So I divide by log 5 minus 2 log 4. Okay? So when I go to type this in, I'm going to just start with a divide by to make a big fraction, and then I'm just going to type log 4 plus 3 log 5, and then log 5 minus 2 log 4. All right, and then that's going to be my answer. Okay, negative 5.342. All right, so that is solving log equations. Okay? So the rest of the worksheet, we just have more practice of those same two types. Okay? We got some log equations here, and then we got some exponentials here. So we're just doing basically more of the same. All right, here we go, part 2. Okay, these are all going to be kind of mixed up a little bit, but a log on the same side, we cross the logs off. Okay, we get 3x squared plus 4x equals 2x squared plus 12. I'm going to subtract the 2x squared over. That gives me just x squared. And then I'm going to subtract the 12 over. Okay, minus 12 equals 0. And this is one that's pretty easy to factor. Multiplies to make 12 and subtracts to make 4 is plus 6 minus 2. So x is negative 6 and positive 2. Now, when I go to plug those in, the positive 2 is fine. It's the negative 6 I'm worried about. But negative 6 squared is 36 times 3 is, I don't know, 100 and something. But 100 and something minus 24 is fine. And then negative 6 squared is positive 36. So that one goes to positive. So actually, both answers are good. This one doesn't have any extraneous solutions. Okay. Let's do our log properties first. When I'm subtracting, I'm dividing. So log base 9 of 12 over k minus 5 equals log base 9 of k plus 6. We have log bases on both sides, so we cross them out. 12 over k minus 5 equals k plus 6. All right. To solve this, I need to multiply by the k minus 5. Don't be too excited when I tell you that that means we get to make a box, right? Because anytime we multiply a binomial times another binomial, okay, we get to make the box. So this gives me k squared plus 6k minus 5k minus 30. And if I combine those together, I get k squared plus k minus 30. And that's going to equal 12. Okay, now I need to get everything on the same side. So I'm just going to subtract the 12 over. So that's 0. That gives me k squared plus k minus 42. I can factor that because what multiplies to make 42 and subtracts to make 1? 7 and 6. And so my solutions are negative 7 and positive 6. Now when I go look, the positive 6 is fine, but the negative 7 makes that negative. So I say, okay, it's not negative 7, and it's only 6. Okay, so again, that's what we call an extraneous solution. Okay. This one, we're going to take, I think we'll put the 1/2 up here. And then we're going to combine those two together. Because it says plus, all right, we multiply them. So I get log base 5 of 5c minus 9 to the 1/2 equals log base 5, and 3 times 2 is 6. Okay, now, I can get rid of the log base 5s on both sides. So I have 5c minus 9 to the 1/2. Really, to the 1/2 means square root, so let me just put that on there. Equals 6. Now, I'm going to square both sides. All right, I get 5c minus 9 equals 36. That's what 6 squared is. I'm going to add the 9 over. I get 5c equals 45. And when I divide by 5c is 9. And that makes everything positive, so we're good. Okay, now, Those three are like a different type than the next three, because the next three are now where we have logs on one side, and these we do differently, right? Okay, so step one, this one's a little annoying with the fraction, but that's okay. Remember, anything that you're worried about doing like that, you can just do on your calculator. Okay, so if you're not sure, like 11 thirds minus 2 is this decimal, but I can hit math 1 and it's 5 thirds. Okay? Now, when we have a log on one side, we go that to that equals that. So I go 8 to the 5 thirds is 7 minus 5w. Now let's think about what this is, you guys. We've talked about this a bunch of times. That means cube root. The cube root of 8 is 2. 2 to the 5th is 32. If you're not sure, go on your calculator. Go 8 to the 5 thirds, and you'll get 32. Okay? All right. So now I have 32 is 7 minus 5w. I subtract the 7 on both sides. I'm going to move this over here. Okay, 32 minus 7 is 25. That cancels out. And then I divide both sides by negative 5. Okay, so I get w equals negative 5. And when I go to test it, even though it's a negative number, because in here we're going 7 minus 5 times w, the minus negative will make it plus. So that's a good answer. All right, let's do this one. That 1/2 right there, that needs to come up to here. And then 9 to the 1/2, that means square root of 9 is 3. Okay, now because of the plus, I'm going to multiply those together. So if I multiply 2r minus 3 times 3, I get 6r minus 9. And you guys are going to remember at this step, it's log base e. We go around like this. So I go e to the 7th is 6r minus 9. If I add 9 to both sides, I get, let me move this over here also actually. E to the 7th plus 9 equals 6r, and then I divide by 6. Now with this one, you guys can write your answer as e to the 7th plus 9 over 6. That would be fine. Or you can actually figure out what that is by going fraction e to the 7th plus 9 divided by 6. Okay? And so you could also put 184.272 for your answer. All right? Okay, great. Okay, let's take a look at number 30. All right, I want to get the log by itself first, so I'm going to subtract 9. That's going to give me 3 times log base 6 of 2h squared minus 14h equals 6. I'm going to divide by 3 because that's easier than bringing it up and making it like to the third power, right? So log base 6 of 2h squared minus 14h equals 2. And then I go boom, boom. So I get 6 to the 2nd equals, oh, sorry, what am I doing? Log is gone. Once I turn it into exponential form, it's 6 to the 2nd equals 2h squared minus 14h. Okay, now 6 to the 2nd is 36. We'll bring that over to the other side. So I get 2h squared minus 14h minus 36. Because of the 2 in front, you could factor a 2 out first. That makes it h squared minus 7h minus 18. And then I believe that that factors, multiplies to make 18, subtracts to make 7 is minus 9 plus 2. So h equals 9 and negative 2. The 2 in front we don't have to do anything with. Okay. I'm pretty sure when I put 9 in, it's fine. The negative 2, I need to check. So negative 2 squared is 4 times 2 is 8, and negative 14 times negative 2 is plus 28. So that one's also good, actually. So both of these answers are going to work. All right? So that's finishing up the little logarithm section here. All right, let's go ahead and take a look at this last part, these exponential equations, okay? So once again, there's two different types, but you'll probably recognize the ones where you can get the same base, like these ones, and then ones where there's just totally different bases that don't seem to match up. All right, let's start here. Okay, that's 2 to the first, and I'm going to bring it up. That's 2 squared. And actually, you guys, 1 is 2 to the 0. So that's a little bit of a tricky question, but you can do that. Okay, so I'm going to rewrite this as 2 to the negative 1 to the 2, 2 squared to the 3d, and 2 to the 0. Now here, I'm going to add those together and then set them equal to the exponent on the other side. Okay, so I get negative 2 times 3 plus 6d equals 0. I'm going to add the 2 over. Oh, whoops. Over here. So I get 6d equals 2. And when I divide by 6, 1/3, or if you do it on your calculator, you can write 0.333. All right, let's look at the next one. This is 3. We said that was what? 3 to the 5th, 3 squared, which I'm going to have to move up, and 3 to the 3rd. So I'll write this as 3 to the 5th, 3 to the negative 2 to the negative u, and then 3 to the 3rd to the negative 5u. Okay? All right. Let's see, we're going to take 5 plus, because it's times right here, I'm adding the exponents, okay? Negative 2 times negative u is just 2u equals negative 15u. All right, I'm going to subtract the 2u to the other side. 5 equals negative 17u. And then if I divide by negative 17, okay, u is negative 5 over 17, or as a decimal we can put negative 0.294. Okay? All right, perfect. Okay, now these ones do not have the same base. We need to get them to have the same base. Step 1, get the exponential by itself. Okay, so I have 18 to the 3n equals 53. Take the log or ln of both sides, it doesn't matter, to bring this down in front. 3n log 18 equals log 53. Now to solve for n, I need to divide by 3 and log 18. Here's a hint. You can do them both at the same time if you want. Okay, the 3 and the log 18 will cancel out. And then I just put this as a decimal. So I'm going to go ahead and type, oh, actually, I was going to do this on Desmos. It's a little bit easier. I mean, you can do it on the graphing calculator, but on Desmos, we can just do, let's see, put the divide by there, and it's log 53 over 3 log 18. Oh, that didn't work. Log, there we go, 18. Okay, and I get 0.457 or 0.458 if you round. Okay, 34. Let's add 5 to both sides. So I have negative 6e to the x minus 2 equals negative, I don't know, negative 144 plus 5. Is that negative 139? Yeah, negative 139. And then I divide both sides by negative 6. Okay, so now we're going to divide both sides by negative 6. That was kind of really what I wanted to know over here. Negative 139 divided by negative 6 is... Oh, that's yucky. Okay. Well, that's fine. 139 over 6. Okay, great. So that just doesn't really divide. Okay, so e to the x minus 2 equals... I'll just leave that as 139 over 6 for now. Now, guys, we're going to take the ln of both sides because remember, when we do ln of e, it crosses out. And I can just bring that down just with ln e, okay? So I end up getting x minus 2 equals the ln of 139 over 6. And then all you guys have to do is add 2. Okay? Go into your calculator. And we're just going to go... Let's see here. ln... Nope, I don't need that divide by yet. ln of 139 divided by 6. And then on the outside, plus 2. Okay? And then there's my answer. X, put it down here, 5.142 or 5.143 if you round. All right. 2 more questions. Here we go. Okay, let's subtract the 5 over. All right, so I get 7 times 9 to the 2r plus 7 equals 15. Divide by 7. That's not going to be a very nice number, so I'm actually just going to leave it as 15 over 7. It's going to be easier to work with. You take the log or the ln of both sides, bring this down in front. So 2r plus 17 log 9 equals log of 15 over 7. Okay, I'm going to divide by log 9. All right. So that equals log 15 over 7 divided by log 9. Okay, there's just like a lot to keep track of here, guys. But at this point, all you do is subtract the 17 over. I don't even really like to rewrite all this so many times. And then divide by 2. Okay? Now, when I go to write this, it's going to be divide. Okay. Log, parenthesis, we're going to go 15 over 7, divided by log 9. And then, nope, over here, minus 17. And then down here, over 2. So the thing I like about Desmos is it does let you put it in the way that you see it on there. And then, you know, it's a little easier to see your answer. Negative 8.326 or 327. Okay? Okay, I just caught a mistake really quick. It's a good thing I was like kind of checking as I was going because this says 7 and I changed it to a 17. I don't know why I did that. So let's go ahead and make that a 7, which makes that a 7, which makes that a 7 that I'm subtracting over, which should change my answer quite a bit. So Well, a little bit anyway. Let's go make that a 7 instead of a 17. So again, that was just a little typo on my bad. Sorry about that. And there we go. So my new answer is it's not letting me get this. Okay. Negative 3.326. All right, negative 3.326. So let me write that up. Okay, let's do our last question here, guys. I'm going to ln instead of log this time. You do whichever one you want. Okay, so I have 2x minus 1 ln 5. I have x plus 7 ln 3. I backwards distribute that. So I have 2x ln 5 minus ln 5. I backwards distribute that. So I have x ln 3 plus 7 ln 3. Okay, I get the x's on the same side. So actually, how am I going to do this? I'm going to take this one over and hit minus. So 2x ln 5 minus x ln 3. And I'm going to take this one over and put plus 7 ln 3 plus ln 5. Okay, I'm going to factor out an x. So from here and here, I'll take an x out. So I have 2 ln 5 minus ln 3 is 7 ln 3 plus ln 5. And then I divide this whole thing over. Okay? And I'm going to go type this in. Okay. So, sorry guys, this is not coming up right. All right, so I'm going to put a big fraction divide by thing, and I'm going to go 7 ln 3 plus ln 5 over 2 ln 5 minus ln 3. Okay. And my answer is 4.386. Okay. There we go. So hopefully that review will help you guys for our test that we have coming up.